start recording now. So anyways, folks, welcome to the Starkle Planetarium's virtual show called the Fall Prairie Skies. We have been doing these every other week this fall, and ever since we got things going on here. I run these with Waylena as a team. You folks might see Waylena over there. Here, I'll actually even put her on spotlight for a moment. There you go. Look at, there's Waylena. Waylena, go ahead and say hi to everybody. She is going to monitor the chat. So if you folks have questions, hopefully you or somebody in your household can type the questions in there. You might also notice that we have the option for raising your hand if you really prefer to raise your hand and ask the question on the microphone. You are more than welcome to do that. She's here to help get my attention because sometimes I get rolling so quickly that I lose track of stuff. All right, so let me go ahead and pin myself here. And I thought I had that option. I guess I don't have that anymore. Oh well, why am I doing that? I guess I accidentally went to full screen. Let me get myself out of full screen here for a second. Why did I do that?
This is what we get for having fun with all those Zoom options that
yeah, exactly.
about as they logged on. Yeah,
I'm still having a lot of fun with the pizza hat. It's just to remind ourselves to look for the summer triangle tonight.
Hover over yourself and choose pin video.
I think I have pin video on right now. So we do have that. There was just I had a little problem where I accidentally turned on full screen and it really threw me off just now. That's all. So, all right. So anyways, I'm going to now share my screen so you all can see what I'm looking at. I am focused on using this free sky simulation software called Stellarium. It's been available for about 15 years now, and it's really nice, folks. You can actually install this on your home computers. It doesn't take up that much data. If you have a Chromebook, it's a little tougher, but nevertheless, Stellarium actually also has a web browser version, so you can use that to simulate the sky. So what you're seeing right now is what the sky would look like right around midday on a very clear day. I'm actually showing you the Starkle Planetarium right now, where we would all love to be giving these shows to you, but we're happy that we can do this for you as well. So what I'm going to do now is I'm going to actually change one of our views of the sky. I'm going to switch my landscape here, and the reason I'm doing this, I'm going to actually one of our local observatories run by a club that is affiliated with the planetarium. It just has to take a little bit of a moment to load up. We've got some comments in the chat already. It's Waylena's comments. Thank you. That's great. So if you check in the chat, Waylena's actually already given some really nice links so that you have a sense of what's going on here. So the photos that you're seeing of the planetarium and of the observatory are actually photographs that Waylena took. She has this amazing 360-degree camera that allows you to get these panoramic views of everything. And the reason why I would recommend we would go out here is because look at how nice the flat horizon is. And you also are getting outside of town. So if you're going out to look at the night sky, I would recommend heading to a site like this where you're away from a lot of the lights so you can see a lot more of the night sky. And so let's go ahead and go a little bit later into the evening. And this is how the day was not like for us because again, we had a lot more clouds. But nevertheless, it's at least good to see here. And I think we had some clear skies the last couple of nights, didn't we? Oh, look at that. Before the sun actually even sets, look at what we've got over here in the southern portion of the sky. Now, you might not know that's the southern portion of the sky, but you can see right here, you notice that S right there? That tells you that you're looking just a little bit east of south. You folks know what we're looking at right here, right? I might not be able to hear you, but hopefully you're saying it right back to me. Yeah, we are looking at the moon. You're seeing the moon right there. And what I'm going to do now is I'm going to zoom in on the moon so you all get a nice close look at it. The moon is visible sometimes during the day, and that's what we're seeing tonight. Notice that the moon is shaped like a crescent right now. And you can actually even see a little bit of an outline of the side that's not facing towards the sun. Now, this might look different if you saw the moon over the last couple of the days. I saw the moon a couple of days ago, and it was a really pretty crescent. You might have seen it right next to Jupiter and Saturn, as a matter of fact. But this one is a little bit more full, isn't it? Okay, and that's the moon showing its phases. Here, what I'm going to do now is I'm going to show you what the moon looked like yesterday. All right, so here's the moon yesterday, and there's the moon the day before, and the day before that. So what we're doing is we're going from, I believe here, this is Tuesday, Wednesday, Thursday, and back towards today. And then here's tomorrow, that's Saturday, Sunday, Monday, Tuesday, Wednesday, and this is what the moon is going to look like on Thanksgiving, right there. Okay, so you're seeing the moon going through phases. And the reason why is because the moon orbits around Earth. The planets orbit around the sun, but the moon orbits around Earth. All right, and these different lighting amounts you're seeing here is just because more of the moon that's lit up by the sun is pointing towards Earth at that time. That's what's happening. But what's really weird, you might notice this if you're paying a lot of attention to what I just showed you. Do you see how the same side of the moon seems to be facing towards Earth? We see the same patterns of seas and so on. That's because the moon does this really weird thing where the speed at which the moon spins around, here, I'll even spin around for you right now. Hopefully I can hold on to my pizza hat. The way that the moon spins around, it spins around as fast as it goes around Earth, okay? We say that it's synchronized in that way. So we only ever see one side of the moon. And it was not until we were able to send things into space that we could see the other side of the moon. I see Waylena is continuing that demonstration of spin. That's perfect. All right, let me go ahead and go and zoom back out here. That was just a little bit of a basic moon phases that you were seeing. So now you know what the moon's going to look like if you step outside after sunset, after you've eaten all that turkey next Thursday, and you're just wondering what's going on out there before the tryptophan makes you fall asleep, okay? So that's what you got to look forward to. All right, let's go ahead and move our view a little bit between where the moon and the sun are right there. And we're gonna go a little bit later into the night. All right, there's our sunset. Oh, hey, look at that. Okay, you might have seen a couple of things zipping past the sky there. I'm gonna ignore those for right now. But for the moment, over to the right of the moon, you see two very, very bright dots, okay? Now, with most of the things you're seeing up here, they happen to be stars, as you would expect. But these two here, they are not stars. You know, if it's not going to be a star, what do you think it's going to be then? Okay, maybe you said it, but we're looking at a couple of planets right here. Now, when it comes to planets, a lot of planets are pretty bright, brighter than, in fact, any of the stars in the sky. But another way you can tell that they're planets is if they don't twinkle very much, okay? Stars, they tend to twinkle, and the planets twinkle a lot less because they're so much closer to us. All right, now I haven't given away which planet this is because I wanted to zoom in on it, and maybe you'll be able to figure it out for yourself. Okay, let's see what it looks like. Oh, look at this. Before, that's a good guess, Ellie. Let's see what's going on here. Before we get in even closer, notice that there are 4 dots around this planet. Let's see what it looks like. Oh, I don't see any rings around this planet, so maybe it's not Saturn, but I do see we've got some stripes there. And those stripes, oh, they're so colorful. I gotta say, this is a really colorful planet right here. We see some whites, we see some browns, some reds, okay? And we see some little tiny ovals on there as well. Yeah, that's right. If that was Tanner or Elijah, I don't know, but that is correct. That is Jupiter. You are looking at the planet Jupiter right there. Jupiter is a humongous planet, folks, all right? And Jupiter is actually more massive than all the other planets and all the asteroids and comets in the solar system combined, okay? And there's another cool thing I wanted to show you with Jupiter here. And let's see if I can get this to work right. I'm gonna go up a couple of hours and let's see what happens. There it is. Okay, so right there, do you see that dot on Jupiter? That big red dot? That, well, let me give you the technical name for it. It's not the big red dot. That's just silly. The real proper technical name for it is the Great Red Spot. I know, sounds really technical, doesn't it? Okay, but yeah, that Great Red Spot right there, you've got clouds all over Jupiter. So if you've got clouds and you see this thing on here that's swirling in a circular motion, a lot like our hurricanes, isn't it? Yeah, that Great Red Spot is circular because it's a humongous storm on Jupiter. And we've seen it, that's right, we've seen it for over 100 years on this planet, okay? Ever since basically we've had telescopes that have had the resolution to see such features on Jupiter. That's how long we've been able to see the Great Red Spot. So we don't know when it started and we don't know when it's going to end. And I told you about how big Jupiter is, right? Well, let me tell you, that Great Red Spot you're seeing right there is bigger than Earth. Yeah, folks, that's a storm bigger than our entire planet. Amazing, right? Okay, let me go ahead and go back. I do need to go back a couple hours again. I think I was just a little bit after sunset, so it was right about there. And I do need to do a couple of other things. There we go. And let's zoom back out. Okay, so that other dot is in view right there. Oh, good. I love it when I blow people's minds. There's some crazy stuff out there. All right. Yeah, thanks for putting the responses in the chat there. That's great. Let's go to our next one. Again, I don't want to give it away. Center on it. Let's zoom in, see what we got. Okay, I see a couple of dots around it. Oh, I think there's something giving it away right here. I bet a lot of you know which planet this is, don't you? Which planet is this? There we go. Hail Saturn. That's right. Saturn is just so beautiful to look at, folks. I gotta say, looking at it through a telescope, it's quite shocking. When a lot of people see this planet for the first time in telescopes, they think you are looking at a sticker on the eyepiece. It just looks fake to them. And you're seeing those beautiful rings on Saturn. Yeah. Oh, I'm sorry. I forgot to put the name up, didn't I? Let's do that. There we go. There's Saturn. Yeah, Saturn, you see those rings. The rings are huge, but what's wild is the rings are extremely thin. Maybe there's been some time in your life when you wanted to make a diorama of Saturn or something, where you wanted to make a scale model size of it, and maybe you just wanted to use something as thin as a sheet of paper. Oop, you can't see the paper now. There, you can see the paper a little bit better there. And to imagine how thin those rings are, if you use this sheet of paper as the thickness of those rings, the sheet of paper would have to be over 1 mile wide. Isn't that crazy? The point is, even though the rings are thousands of miles across, over 100,000 miles across, in fact, they are less than 1 mile wide. A mile thick, I used the wrong word. They're less than 1 mile thick. Yeah, they're usually only about as thick as a tall room. That's really all it is. But yeah, they're beautiful to look at through a telescope, and the photographs you can get of them from Earth or from the Cassini space probe that orbited around Saturn for the last 13 years are just amazing, okay? And that's just another really cool thing I'll share. Now, as you folks can see, Jupiter and Saturn are really close together in the night sky right now. Oh, I didn't turn that on correctly. Oh, did I do that? I did. Okay. They're really close together in the night sky. You can see them there compared to the moon tonight. Yeah, this is tonight at about 5:16, so this is 2 hours ago. But notice what it looks like in a couple of weeks. Here's where they look like tomorrow. And you see Saturn, it looks like Jupiter's actually getting closer to Saturn. So if you are going to look in the next few weeks, you'll see they're a little bit lower over more towards the southwest, but you're going to see they're a lot closer together, okay? And by mid-December, you might have a hard time telling them apart, as a matter of fact. This date right here, this is on December 16th, okay? So this is a few weeks from now, and you see how close together Saturn and Jupiter are. In fact, they're actually probably getting closer together than what you'd see with the moon. Okay, let me see if I can zoom in on this correctly. No, that's a little too close, isn't it? All right, I'll zoom back out just ever so slightly. So there you see Jupiter and Saturn. And I think at this distance, I just want to confirm for myself. Oh yeah, that width that I'm showing you right there, that's about the width of the moon, okay? So they're going to get closer together than the moon in those days. The closest they'll get together is actually on December 21st. Look at that. That's a little busy right there. I'm going to do this. So they're going to get so close together on this date that you'll be able to see the two of them in the same field of view in a telescope. Okay, so if you've got a telescope, you'll actually be able to see them both together. They'll actually look kind of like this. Well, that's a lot farther apart there, but you want to get a better eyepiece to get them even closer there. All right, just going to be an amazing sight to see. In fact, they'll be closer together that night that we see from Earth than we've seen since 1623 in almost 400 years. Okay.
Hey, Eric,
Yeah.
I want to interrupt and mention that on December 4th, after the science lecture, we'll have another one of those special edition Prairie Skies, and it's going to be all about Saturn and Jupiter. So if you want to see even more of those two and find out more about watching them as they appear closer and closer together, that'll be a good time to get with us. That's December
right.
4th.
Going to be focusing on that a lot more than right now. In fact, I think I just posted that event to Facebook like today. I didn't get around to that. I think I called it Spotlight on the Great Conjunction. So yeah, it's going to be really cool. But even if you don't catch it that night because it's cloudy or something, you're going to see them pretty close together throughout the month of December, and that'll be a really nice treat. All right, I know I get carried away with these things, but I think they're just so fun to look at. Let's see here. Before I go any further, let's go ahead and go a little later into the night because those bright objects, we've already seen those now. So I can zoom out a little bit more here. I got some star names up. You want to see the triangle? Excellent. I'm glad you were reminded of that. You probably thought about the pizza on the top of my head, and that's what you were thinking there, Ellie. Okay, so let's go ahead and bring the triangle to you. So just to the right of Jupiter and Saturn, do you folks see this little cloudiness right there? That there is the Milky Way, okay? And this is at the time at about 6 p.m. tonight, and it would get pretty dark that if you're far enough away from city lights, you might be able to see the Milky Way. I think you'd have that ability. Obviously, it has to be clear skies. But the reason why I bring that up is because if I follow the Milky Way up like this, I'm going up pretty close to where the zenith is. Let me see where the zenith is. Yep, that's where I thought it'd be. So we're not quite at the zenith, but we're close to it. And right around here, I'm going to go ahead and do a little bit of drawing. Everybody loves it when I draw. Okay, so I'm going to draw from here to there, and back to there. So there we go. Ellie wanted to see the triangle. You are all now seeing the triangle. Now, we call this the summer triangle because in this part of the sky during the summer, this stuff is rising right after the sun sets. So you'd see it basically all night, okay? But that said, right after sunset, this stuff is really high up all through the fall. So it's a really good fall triangle as well, okay? Yeah, and we see this group of stars right here. And those stars' names, let me see if I can turn them on right now, even though I've got the annotations going. Let's see if I can do this. There we go. Got all three names of the stars right there. So we've got Vega, Altair, and Deneb. Okay, and they might be pronounced differently by other folks. I'm sorry, I just have my conditioning for how I had learned how to pronounce them a long time ago. Or I use the Street Fighter game to choose the name of a certain star. Okay, but there we've got Vega, Altair, and Deneb. All right, and what's interesting is that each of these three stars, even though they're all part of the summer triangle, they're actually parts of different constellations. So Vega apparently is Ellie's favorite. Let's click on Vega right now. And I want to show you what constellation it's in. Looks like we've got the other one there too. Let me see if I can do this correctly. Oh, no, there we go. Okay, so the constellation Vega's in, let's take a closer look at it. I'm going to actually turn off that drawing. Hopefully you folks will forgive me for that. All right, so let's close in much closer on this tiny little constellation. What does that look like to you folks? Maybe it looks kind of like, I tell you, they don't draw the same way I do. Usually I see people thinking it looks like a necktie or maybe a tiny little fish, but I'll tell you, not a lot of people see it look like, oh, I hit the wrong one. They don't really see it looking like this little harp, okay? Oh, a dipper. Yeah, I could see it as a dipper. That's a very good possibility, a very tiny little dipper. I could see that. But yeah, apparently the ancient Greeks, they saw it as looking like a little harp. Now, this is not one of those big harps you see in concerts. This is a harp that you see angels plucking in old Looney Tunes cartoons. It's called a lyre, and that's where it got its name from. It's called lyra. All right, and I see I did not put the font up there. So I'm gonna make one little fix here because I forgot to do this. Thanks for your patience, everybody. That's a lot easier to see now, isn't it? Okay, yeah, so that's Lyra right there. All right, and so you're seeing the constellation of Lyra. Now, let me go ahead and turn those off, and I wanna show you the next of those stars. Whoops, okay. And let's click on Deneb now, and we'll see what Deneb's all about. Oh, that's interesting. Maybe you see that looks like somebody with a jump rope. Maybe you see it looks like an airplane. Or you're seeing an Egyptian there, Waylena? Is that what you're doing? Okay, well, let me show you what we've got right here. We are seeing a swan, okay? Or maybe you saw a goose, but maybe you don't want to see that many geese. I understand that. But this is supposed to be the swan, and the Latin name for it is Cygnus. Cygnus the swan. So Deneb is part of Cygnus right there. And another way you could see this, notice that along the middle here, it kind of looks like a cross shape. A lot of people call this group of stars the Northern Cross. Okay, let's turn that off now. And let's go to our next one. And now we're going to click on Altair. And let's see what we've got there. Oh, look at that. With Altair, we've got another person that looks like they're jumping up in the air. Okay, yeah, there you go. You see them jumping up in the air. Or maybe you see a different airplane. Who knows? That's all right. Remember, these star shapes, you could see anything with them. And also different cultures see them in different ways. So they have different names for these groups of stars too. Okay, so with Altair, it's actually an eagle. Okay, I got to get that to work for me. Come on now. There we go. Much better. And yes, that's right. That's right. Good job, Tanner or Elijah or anybody in their family. This is Aquila. Aquila is the name of the eagle. So the summer triangle has stars in the constellations of Lyra, Cygnus, and Aquila. Pretty cool, huh? All right. So those groups of 3 stars, you got 3 different constellations right there. All right, now I'm going to show you folks a group of stars that you all are very familiar with. Let's see if I can bring this up correctly. All right, I'm going to switch over to a different part of the sky. All right, and we're going to move over to the right here. I actually want to turn off those star labels. Oh, wow. I accidentally turned on the asterisms. I just learned how to turn on the asterisms. That was wild. All right, I went too far. Okay, so over here, I am looking in a part of the sky where I see a group of stars that I can really recognize. And I bet maybe you can see them too. It's pretty low to the horizon. In fact, it's so low, you might have a hard time seeing it at this time of the night. But I see these 2 stars, 3, 4, little trapezoid right there. Let's go all the way through that and we'll finish that off right there. I think somebody saw a dipper before, but this is a much bigger dipper right here. We see, oh, look, Tanya's here. Okay, we see the Big Dipper right here. You're seeing the Big Dipper right now. And if I were to click on this, yeah, the Big Dipper. If I were to click on this, you might see a few more stars, and that's because the Big Dipper is part of a constellation known as the Big Bear, okay? So if you ever hear somebody call the Big Dipper Ursa Major, yeah, that's right, okay? It's because the Big Dipper is part of the Big Bear, all right? Now, there are 2 very important stars in the Big Dipper I want to highlight here, okay? And I'll use the same highlighting marker. I'm not going to change. Actually, I can change the color. Yay, I can do this. I love it. I'm going to go from this star right here all the way up like this. And it goes right past a really bright star up there. And I bet if I do the right thing here, I'll be able to see its name. Let's see what happens. I was wrong. That's okay. I'm going to click on it this way. Here we go. So it is in the constellation Ursa Minor. That's true. But what I wanted to show you is that you are looking at the star Polaris. Now, let's not worry about all those other names because those I honestly don't know myself. I completely forgot about them. Love forgetting all my settings. It's just so fun. All right. So yes, you are seeing the star Polaris right there. And what we just did from the Big Dipper is that we pointed to Polaris. Okay. And you see that Polaris is part of the constellation Ursa Minor, which you can imagine if Ursa Major is the big bear, Ursa Minor is the little bear. But it probably is not what you folks usually call it. It's actually the Little Dipper is probably what you call it, right? Yeah, this is the Little Dipper right here. You can see how close the Big Dipper and the Little Dipper are in the sky. And what you might remember from now on is that Polaris is at the end of the handle of the Little Dipper, okay? There's lots of little tiny dippers out there. If you want to think of Lyra as the tiny dipper, you certainly can. We're going to show you another tiny Little Dipper later on as well. All right, I got to clear out all these annotations, otherwise they're going to stay up there. So let's turn those off. Perfect. And let's get this off as well. Dippers everywhere. Dippers everywhere. That's right. Okay, so let's take a look around here. And I think I've got one more planet I'm going to show you folks because I know you folks love to look at the planets. If you can see, I've got the moon back over here. We're looking back towards the south once again. Okay, I know it can be a little disorienting because I'm moving around the sky. We're looking over in the southeast. I've got my cardinal directions up once again. Maybe that'll help keep you folks straight here. And over in the southeast, I see a bright object here, and it's kind of a little bit reddish shaped. Okay, maybe this helps jog your memory. Do you know any planets that are red? Bet you do. Ah, they already said it. Let's take a look. It is Mars. That's right. Let's go ahead and zoom in on there and see what we've got. Oh, there we're now seeing the red planet, and I bet those are Mars's two moons right there, but I'm not going to click on them. We're focused on Mars right now. There we go. We're seeing Mars right there. And yeah, we see a lot of that red, but we see actually a few other neat features on there. Mars is a very geologically interesting planet. And one feature that I can tell just over on the right edge here, this is actually the largest volcano in the solar system. It is Olympus Mons, and I'm clicking on all sorts of tiny little features on Olympus Mons right now instead of the main feature itself. But that's okay. I'll forgive myself. But yeah, Olympus Mons over there is a humongous volcano. It's not active, but it's a humongous volcano. To give you a sense of how big it is, it's actually the size of the state of Missouri. Did you want to replace the state of Missouri with a volcano? I hope not. That's not very nice. But maybe at least during one of the games between Illinois and Missouri, I would maybe at least tolerate it then. All right, but yes, that's Olympus Mons right there. Mars is an interesting little planet. Oh, my sister who lives in Missouri just responded to me. Probably shouldn't have said certain things. This is going to go great up on YouTube. All right. Okay, so yeah, you see Mars tonight. Now, what's interesting, I've covered 3 planets so far and the moon, but there are 2 other planets that are up right now that you can't see because they're too dim. And since I don't know exactly where they are, I'm going to actually cheat for us right now to help me find it. I'm going to open up my search window and I'm going to type in the next planet that's right after Saturn. This is Uranus, is where we're going to go next. Uranus is just to the right of Mars. Oh, to the left of Mars. Shouldn't have assumed. That's right. Neptune's the one that's to the right. And I wanted to show you folks Uranus just so you could see it, so that you could say you saw all the planets tonight. All right. All right, we got a couple of moons there. There's Uranus. Oh, what do I see around Uranus? Oh, look at that. There's some really, really thin rings. From Earth, we have a very hard time seeing the rings, especially in visible light. In fact, we actually had to discover the rings around Uranus over 40 years ago when they blocked the light from a star that Uranus was passing in front of. Okay, it was a really neat way that they discovered that. And however, we can see the rings a lot easier when we look in infrared. So maybe you could imagine this picture is based off of that. Now, when you look at Uranus, you don't see a whole lot of details. It's just kind of a pale blue dot, or maybe kind of a pale aquamarine or cyan dot. There's a little bit of a green tinge to it. The reason for that color is because Uranus's atmosphere has a lot of methane. Okay, yeah. And I'm betting you folks know exactly where we get a lot of our methane from. That's right, cow farts. So it's a good thing to think about when you think about Uranus. All right, let's go ahead and we're going to do another planet that's up here. And this one is over to the right of Mars. And this one is also pretty dark because it's even farther away. We're going to find Neptune. There it is, between Mars and the moon. Let's zoom in on it. Ooh, look at that deep blue color. That's perfect because Neptune was named after the Roman god of the sea. You might know his Greek equivalent, Poseidon. Okay, so when I look at this blue planet, I really think of the oceans. Okay, oh, it's a lot wobblier than I expected. Let's go ahead and do that. And you do see a ring system around this one too. And it's blue because just like with Uranus, it has a lot of methane in its atmosphere. But it's not as featureless as we saw with Uranus. There's less haze in this atmosphere. And you're looking at this famous feature called the Great Dark Spot that was photographed by the Voyager 2 spacecraft over 30 years ago. What's interesting is that unfortunately for both Uranus and Neptune, we don't have a whole lot of pretty pictures of these two planets because we've only sent one spacecraft that flew past both of those planets. Okay, back in the 1980s. And then after that, it just kept zipping on farther into space. So we've never had any spacecraft orbiting around them so that we get constant observations. That would be really nice to see. But for now, we have to do photography from here on Earth or just enjoy those pictures from the 80s. All right. Okay, so now with that, I want to show a couple of other cool features that we can see here. This is only the sky at 6 o'clock. So we're seeing a few things up here. And if we go later into the night, they'll get even higher up. So let's go ahead and we'll go to 9 o'clock. All right, here we go. Actually, I probably need that up so I can actually see the time. All right. That's a little bit after 9. Perfect. All right. Now, you might recognize a couple of things over here in the east that have just risen, all right? And I think I'll focus on probably the most famous constellation in the night sky. I say this because the stars that are there are so bright and it's known by such amazing names around the world as the Warrior or the Hunter. Yeah, it's got lots of cool names like that. I think the Chinese might even just call it the Seven. Okay, I'll have to go and check on that one more time. But nevertheless, these really bright stars that you see here, there's this nice red one here, there's another bright blue one right there, and we see 3 in a nice noticeable belt. Okay, yes, and that's exactly right, Christina. You are looking at the constellation known as Orion. Okay, I'm going to turn off all the others there. I'm going to turn off all the others there. All right. You're seeing Orion the Hunter. Okay, there's Orion's name, and here you can see some nice artwork for it. We'll go ahead and zoom in just a little bit closer on Orion so you all can see that. And if you're curious about the names of those really bright stars there, let me see how many of them come up when I press this button. There you go. So that reddish star is known as Betelgeuse, okay? Maybe you pronounce it Betelgeuse, that's fine. And we've got Rigel over here on the right foot. That's actually what I tell my students to remember its name because it's alliterative. Alliteration is really useful. And then there's a name up there that probably has reminded a few Harry Potter fans, hasn't it? Right over here is Bellatrix, okay? Yeah, J.K. Rowling actually took a lot of names of characters and other features from astronomy, okay? Remember Draco Malfoy? Draco's a constellation, okay? And Bellatrix was strange. She was named after this star right here, okay? So yeah, this is coming up. You'll see it a couple of hours after sunset tonight, but it's more of a winter constellation, so you would see it a lot better as the months roll on here. So after the new year, you'll see this all throughout the night. So you can start to look forward to that. Now, we're going to do another thing with the Orion's belt right here. We're going to actually follow Orion's belt upwards. I'm going to draw another line because I know you folks love it when I draw lines. What color should I use this time? I'm going to go with green. Here we go. All right. Christina, if you don't mind, I'm going to turn off your video. Okay, thanks. Let's see here. We're going to go up that way, and it goes right past. There's really interesting features here. You see that star Aldebaran, and Aldebaran actually is part of this V shape right there. It's on its side right now, so it's maybe more of a greater than, less than symbol right there. So those of you who have been doing inequalities in math class, you can see that right there. But I want to focus on this little cluster of stars right there. That cluster of stars that you see there, let me clear this out so you can get a better look at this. All right, I'm going to focus on it there, and let's zoom in. So you folks have been talking about tiny little dippers, haven't you? Do you see a tiny little dipper there? Yeah. So this tiny little dipper is a really famous one. This is one you can easily see with the naked eye. Although I recommend, if you have a pair of binoculars at home, you really want to point them at this group of stars because it's gorgeous. Okay. We normally call this the Seven Sisters, but there are over 1,000 stars in this cluster, and we generally refer to it. Ooh, I think I turned on some artwork right back there, and I'm going to cheat here for just a moment so I can turn on this correctly. There we go. Oh, I got the nebula. Oh, of course I did. Okay. We are looking at the Pleiades. And the Pleiades are known as the Seven Sisters because you can see probably about 6 stars without using binoculars, or you'd see a lot more if you get some binoculars on, okay? And those bright stars in the Pleiades, they probably look like a tiny little dipper right there, okay? And the names of the Seven Sisters are the names of these brightest stars in the Pleiades as well. I'll probably just go and turn those off right there. That helps a little bit, okay? And then you might notice another neat name up here too. You see the name Subaru? Yeah, people cannot ignore that one. When it comes to calling it Subaru, the reason for that is because the Japanese refer to this cluster of stars as Subaru. So the next time you see a Subaru car, look at the plate, the marquee, the logo of it. You will see 6 stars on there, okay? And that's because they intentionally named their company after this cluster of stars that Japanese car company did, okay? Let me go ahead and zoom back out here. All right. And you see that the reason why Taurus is up there, if you're curious, it's because the Pleiades are part of the constellation of the Bull. That's what you're seeing right there. Okay. Now, I have to admit, there's one thing I haven't done here, and I should at least show one of them, and I think I'll do this. This is fall prairie skies, so I should show something cool from the fall, and I think this is what I'm going to do. I'm going to show you an object that you can see under clear skies without using a telescope. It's actually the farthest possible thing you can see with the naked eye. Okay, and here's how we're going to find it. I'm going to show you exactly how we do this. Just up and to the right of Mars, I see 4 stars here, 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 and here, and those 4 stars form this kind of diamond shape, and that diamond shape is in the constellation called Pegasus. Okay, and I'm sure a lot of people love Pegasus because a lot of people love horses. And what makes a horse better? If you give it some wings, right? So there you go. Pegasus, the winged horse right there. And Pegasus, the winged horse, is going to help us find our last object up here. And I'm going to give you one more line to draw, okay? And let's go with the color purple, okay? I said purple intentionally. I know what I did. And we're going to go this way, right there. And I usually end up pointing to this star. And then that reminds me to go up from that star, and just to the left, just to the right of this star here, you see right there, there's a tiny little bit of fuzzy oval. Very hard to see, I'm sure. All right. But I bet, I accidentally just saved my drawing. I bet you folks will be able to recognize this in just a moment. Let's click on it. Ah, look at that. There's a woman right there. That's because this is in the constellation of Andromeda. Maybe that's a clue for you folks. Maybe you'll know exactly what I'm looking at here. Let's zoom in on it. Oh, look at that. This thing came in quick. And that's because this, when you can actually see it really nicely in photos, it actually takes up more space in the sky than the moon. It is really big. And you are looking at a galaxy, folks. This is the Andromeda Galaxy, okay? And this is the closest spiral galaxy to our own galaxy. You saw the Milky Way earlier? Well, this is basically the Milky Way's sister. That's a good way to think about it, all right? And like the Milky Way has a few galaxies nearby it that are smaller, and that's what you're seeing over here down to the right. That's the satellite galaxy of the Andromeda Galaxy right there. And the Andromeda Galaxy is very close to us. That's why it's so big. It's only just over 2 million light years away from us. I know, that's an unfathomable number right there. It's huge, okay? What this means is that the light you see from the Andromeda Galaxy traveled through space for over 2 million years before it went into your eyeballs, okay? Yeah. And you're able to actually get enough light from it that you could see it without a telescope. It's very faint, but you can actually see it. So you'd have to go to a place without much light pollution. Okay, all right. So yeah, it's a subject of a lot of scientific studies. In fact, the Andromeda Galaxy is the reason why we have the term galaxy. It's why we understand that galaxies are galaxies, in fact. And that's something we only learned 100 years ago. Really neat stuff. Okay, it's one of my favorite objects to look at. And sometimes you'll see a picture of the Milky Way depicted looking like that. It's usually because they actually take a picture of the Andromeda Galaxy and they say it's the Milky Way. The lies people tell, I tell you what. All right, so with that, let's go ahead and go a little bit later because this is only 9 o'clock. Let's see what's coming up over here in the east over the next few hours. Got lots of bright stars over there next to Orion. I can't spend too much time with them because I see that I'm already kind of running out of time. Ooh, I do want to focus on that one. Just over into the left of Orion, in fact, I'm going to draw again. Let's see what color I pick this time. I'm going to pick orange. Aren't you glad I didn't say banana, huh? All right, let's see what we have. Right there. Okay. This is so fun to draw it myself. All right. We do not do this when we're in the planetarium because we have lovely animations that Waylena makes for us, or at least sets up for us, that we can use to pinpoint these things. And so what we just did is we just drew a line going from Orion's belt to the brightest star in the night sky. And the brightest star is right there. It's not brighter than Jupiter is probably tonight, but there are times when it can be brighter than Mars as well. So it's quite bright. It's brighter than a few planets, of course, and it's brighter certainly than any star. All right, so let's go ahead and see what we have here. This one is Sirius. Remember how I was telling you about Harry Potter? Yeah. Now, you remember Sirius Black in those books or in those movies. And Sirius, he turned into a dog, didn't he? Look at that. There's a dog right there. Sirius is part of the constellation Canis Major. And you might know Sirius's nickname. It's referred to as the dog star. Okay, and that's because you could think of him as the dog tag. It's a really bright dog tag right there around the collar of the dog, the big dog constellation right there. Okay, so there's Canis Major right there. So yeah, Sirius Black got named right for that. Big Harry Potter night I'm having. Okay, that's okay. Now, let's go ahead and go later into the night. I'm going to deselect all of those and I'll turn these off. And let's see what we have next. Okay, stuff coming up over here in the east. Oh, look at that. Do you see over on the left? You see that's the Big Dipper right there. Notice the Big Dipper is getting higher and higher. It's getting a lot easier to see at night. If you're curious about what time this is, I think, yeah, this is at about 4 a.m. Okay, so you see the Big Dipper is getting really high up there. And I think I just found the next thing I need to point at, It's just rising right now. So for some of you, if you actually get up at 4 a.m., this is the sky you'd see before dawn. And I'm pretty sure I do get, okay, I wanted to make sure I had my atmosphere on. So you're not seeing actually any pre-dawn twilight right here yet, okay? And just over here, just at the horizon, is our next object to share with you folks. Let me go ahead and see if I can bring this up a little higher here. There we go. Okay, yeah, sky is actually starting to get a little brighter at this moment because this is actually after 5 a.m., okay? Are any of you waking up your parents at this time? It's a little early, but at least you could see the stars then. So right here, this is the next one I'm going to point at, all right? And I'm going to zoom in on it just so you can see what it looks like. Ooh, look at that, kind of yellowish, isn't it? Interesting. Oh, and I don't see the whole thing. Whenever you see a world that looks like this, it's because you're not seeing all that reflected sunlight off of its surface or off of its cloud tops. And that happens with this planet because it's closer to the sun. What you're looking at right here is the planet Venus, okay? You're seeing the planet Venus right here. And Venus shows phases just like the moon does. And so does the other planet that's closer to the sun, Mercury. And I might be able to get Mercury here in just a moment. But yeah, that's Venus right there. And Venus is going to be the last thing we see before the sun comes up, okay? And the reason for that is because Venus is brighter than anything in the sky, all right? That's at night, that's not the moon, okay? So at this time, we actually often call Venus the morning star for this reason. Okay, and there's Mercury just starting to come up as well. I kind of gave it away because I turned on the labels. And here, I'll show you what Mercury looks like as well. Mercury should show a phase to this as well. There we go. Yep, you see it's cut off too there. And yeah, some folks who had gotten on a little early, they were telling me how they really liked Mercury too. And Mercury reminds me a lot of the moon as well. Very similar colors, covered in craters. Not much of an atmosphere to speak of, and yeah, it zips around the sun really quickly. So Mercury is a very, very fast planet, but it actually rotates really slowly, okay? So that's Mercury right there. All right, so yeah, you're seeing Mercury coming up right before sunrise, and I think you might be able to catch Mercury if you've got a very low view of your eastern horizon. Let's take a look here and see what happens. All right, notice that the sky is getting a lot brighter now. It's because dawn is just about to come up. This is 6 a.m. right here. You probably would have a tough time seeing Mercury by this point, and certainly any of the other stars. I have to enhance the brightness of the stars for this stream just to make sure you all can see it. But as I said before, notice that everything is moving out of view except for Venus. Again, that's why we would call Venus the morning star. And there are times when Venus sets after the sun, so you'd call that the evening star. But that's what we're seeing right there. And now the sun's coming up. There's probably the sun label right there too. We don't need that anymore. And we already know that the sun's coming up a little bit south of east. This is the eastern part of the sky because that's where the sun always rises from. Maybe sometimes a little bit north of it, but still. But there you go. There's a new day right there. All right. Folks, it's tomorrow. You just hung out with me all night. Are you sleepy? I bet I lost a little bit of my audience in the last 45, 50 minutes, didn't I? That's okay. All right.
Hey, Eric.
Yeah.
A couple of things. One, I'm going to put the link to our star charts in the chat, so you can download PDF of the star chart. We've got the current one for fall. We've got the one coming up for winter, and put up the one for next spring. Since last spring we didn't get one because we were, in lockdown and couldn't get into the building.
Yeah.
So we have that. And I did want to mention also to everyone about a little bit more about Mars. there is a mission on the way. Well, there's more than one, but there's one that we're really super, super excited about, mission on the way to Mars. And it's going to be getting there February 18th. We don't have it planned out yet, but we will be having a celebration for that. It'll actually be in the middle of the afternoon, which is kind of nice. Although I know at least one person who's in this audience watching who was very excited to be hosting a whole bunch of you at the wee hours of the morning for a Mars landing. And Erik, were you around for that too? I think you were really
I think I was there for the Mars landing one. Yeah.
Yeah,
The one that was a little bit
I
after
see.
midnight.
I know that my husband went, but I slept. I just could not wake
Sleep
up.
is
I was just really
important.
tired. But I wanted to let everybody know about that. But also, I'm going to put a link to information about that mission in the chat, because I know that we have a couple of people, young people, who were telling us before we started about how much they like Mars.
Oh yeah.
And I think Tanner in particular was telling us how much he liked Mars. So
Yeah.
I wanted to make sure to have that in the chat also.
I like how we're going to have a helicopter on Mars. That's going to be a lot.
I know.
That's really cool.
Isn't that great? There,
Now,
I'll put a link to the helicopter in there too.
Sure. Now, you reminded me, I think what I'm going to do now is just show people our website so that they can see our all the information that we have to offer. What Waylena was talking about off of our homepage right here, educational resources. We've got some cool things like sensory-friendly documents and so on. Our Tonight Sky column that's written by our retired director, Dave Leake, who's actually on the call right now as well. And here's our star charts right here. Okay, so Waylena already has made the next two right there. So if you want to see what fall looks like, I click on this, and that's what Waylena has right there. So you could actually print these out at home, and we have not made a video yet about how you would hold these up, but the idea is that you hold this up over your head.
Yes.
And that gives you a representation of the sky. Another way to think about it too is that if you're looking towards the south, you need that south portion at the bottom. If you're looking towards the west, you need that west portion at the bottom of the sheet of paper. So you need to turn it 90 degrees. Okay.
No, I've recorded that video, but I haven't. Yeah, I haven't put the video together yet. I've recorded it, but I need to put it together. So it's going to be a VR 360.
Yeah. So you can find that information right there. And in addition to that, you can find information about other upcoming shows. We keep a calendar up there with links to upcoming shows. We've been doing these Prairie Skies every 2 weeks, as I said. And then we also have our Kaler lecture series right here. And our next time we'll be doing one of these public shows will be the next Kaler talk. And we have a microbiologist giving a presentation about how we might go up and provide new treatments for drug-resistant bacteria. Okay, staph infections, you've heard about those before, and sometimes they're a little antibiotic resistant. So they're trying to find a way to attack them using bacterial viruses, making viruses do good work for us. Isn't that cool to think about? I know. All right. So yeah, that will be our talk in 2 weeks. And then we'll have another Prairie Skies at 8 o'clock, as Waylena said, focusing on the great conjunction of Jupiter and Saturn. So with that, I'm going to stop sharing so you folks can see.
I think Ellie has a question in the chat.
Yeah. How big is Pluto and how many Mars can fit in the sun? Oh my goodness. That's a number I haven't thought about right there. Okay. Regarding how big is Pluto, I can tell you that Pluto is smaller than any of the planets, and it's smaller than the moon. Okay. I feel bad that I don't have a quick image to bring up that would illustrate this very nicely. I'm going to give you a link to a cool YouTube video that I have used many times in the past. Okay. Let me see here. I'm going to try this one and just share this link in the chat window. It's this cool video called Star Size Comparison. I don't remember if they show Pluto in it, but it shows you how big many of the planets are compared to each other and how small they are compared to the stars. Here's what I can tell you about the size of Mars. Mars is a lot smaller than Earth, but it's bigger than the moon, okay? I don't remember the exact radius, sorry. But I can tell you that 1 million Earths can fit inside of the sun. And if Mars is a lot smaller than Earth, that means a lot more than 1 million Marses can fit inside of the sun. Is that a good answer to your question with that? Okay. All right. How many Plutos can fit in the sun? Oh my goodness. Okay. So I'm going to make a silly little point here. Let's see. Pluto is smaller than the moon. The moon is 4 times smaller in terms of the radius compared to Earth. So the moon has 4 times smaller radius, so that means it has 64 times smaller volume. Okay? That means over 60 million moons can fit inside of the sun. So a lot more than 60 million Plutos can fit in the sun. Maybe that answers Loretta's question. Maybe not. I'm not sure. Wow, that's quite a question from Ellie. How many Saturns can fit in the galaxy? All of them.
I would say all of them.
All of them. I was going to say all of them.
All of them.
Okay. All right. Let's see here. This one is a really, really crazy one.
Hey, according to Google, the Plutos in the sun, it says 188,757.1 Plutos can fit in Jupiter. So from that, we could
multiply that by 1,000.
Yes. So that might be the easier way to get to that one.
So 188 million, basically. So I was off by a factor of 3. Hooray for orders of magnitude. My brother-in-law will love that one. All right.
Crazy.
So,
Awesome.
so you see how small Saturn is compared to our solar system. Ellie, I'm going to share with you another website that I love to share with my classes. Okay. I'm typing into Google, if the moon were only 1 pixel, okay? And this is an amazingly large website, a web page, I should say, okay? And I'm gonna share it on the screen now so you can all see this. Okay, so this is, as it says, a tediously accurate scale model of the solar system. Do you see the scroll bar at the bottom? Do you see how small that bar is? So I'm going to scroll over to the right, and do you see that tiny little dot? You probably can't because this is being fed through Zoom. There's a little dot where my cursor is, representing how big the moon is in this size scale, where the moon is only 1 pixel. Do you see how big the sun is? Now you can see why almost 100 million moons could fit in that sun, okay? But imagine this now, Ellie. Look at all the blackness around you. That's space, okay? That's space right there. And now you're seeing how much space is just in the solar system, okay? There's Mercury. I can actually cheat. I'll go to Earth this way. Oh yeah, I forgot it animates it really nicely. There's Earth and the moon right there. So look at how much space is between Earth and the moon and how small that is compared to this website. Okay, and now we're going to zip all the way over, all the way over here at the end. That's where Pluto is. Okay, and that's just our solar system. Okay, now you wanted to see Saturn at the size scale. Here it comes. Oh, that's going to be Jupiter. Sorry about that. I have to go back. Come on, there it is. Do you see how small Saturn is right there? That's how small Saturn is in this size scale. So as we had jokingly responded by giving you a non-answer, Ellie, all of them, all Saturns can fit into this galaxy because our galaxy has over 100 billion stars and probably that many planets. And the most amazing thing to imagine is how much of that is occupied by space, the space between them, okay? There's a lot of emptiness out there. That is why when galaxies collide, an actual collision between stars in such an event is extremely rare because there's just so much space between the stars. Okay. All right, I blew your mind again. Yes, yes. Okay. Thanks for the kind words, Loretta. We really appreciate that. Do you folks have other questions for us? Okay, here's what I'm going to do to allow you folks to ask more questions more freely. I'm going to now stop the recording